Welcome back. In this class, we are going to continue other forms of Cmos logic. Here, we are going to discuss about dynamic Cmos. Okay, a dynamic Cmos consists of a pre-charge transistor and an evaluate transistor. Okay, and these two transistors are commonly connected to a global clock. Since the clock is going to be comes into the picture, this is known as a dynamic CMOS. Is it clear? Now you can observe very clearly one more time here. You can talk about this pre-charge transistor and an evaluate transistor. Okay, and you are having a logic block. What is this logic block? If somebody asks you, don't forget it is NMOS network. This logic block is your NMOS network. Is it clear? Now here very important point, is it mandatory to use only NMOS network? Is it possible to us to use another network which is a PMOS network? Yeah, absolutely, it is possible to use a PMOS network also, but don't forget here a very important point. If you are using NMOS network, the output should be taken between PMOS and NMOS. That means here you have to talk about the output. When you are talking about a PMOS network, then the output should be taken here. Is it clear? That means this section becomes PMOS and this section becomes NMOS. Is it clear? If it is a PMOS network, once again I am telling that instead of taking an output here, you have to take an output here. Is it clear? If this is an NMOS network and you have to take an output here. Is it okay? Now let us assume that I am taking NMOS network. Okay, therefore this is the node where I have taken the output. Is it okay? Now first of all understood what is this dynamic CMOS, how many number of transistor it consists of. Previously we know very well in pseudo NMOS how many number of transistors we consist of. Absolutely, n plus 1 number of transistors it consists of. By looking its basic structure, the dynamic CMOS consists of how many transistors? Anybody? Absolutely. How many? N plus 2 number of transistors. Why? Because it depends on the number of inputs n, then extra you are having 1. That means n plus 2. Is it clear, all of you? Now first of all understood, this is a pre-charge transistor. Why we are calling this one as a pre-charge and why we are calling this one as an evaluate? Therefore based on these two, we are having two phases here. The phase number 1, okay, pre-charge phase, we can call it as pre-charge phase, and the second one you can call it as evaluation phase. What is that? Evaluation phase. Is it okay? Now first of all we'll talk about pre-charge phase, later we will discuss about evaluation phase. Now you can observe that. Let us consider I am taking one important thing here. I would like to design 2 input NAND gate based on this 2 input NAND gate using dynamic CMOS. Is it okay? Now you can observe very clearly how it looks like. Yeah, absolutely, you must have a pre-charge one. Okay, it is a bubble, you have to understood it is a bubble. You have a pre-charge one, and here you have to draw a network. What is that network? I already said that NMOS network. We know that in NAND gate NMOS is going to be in series. Is it clear? Therefore you are having a series combination because of 2 inputs. Let us consider A and B are the inputs, and you must have an evaluation transistor. This is an evaluation transistor. Let us understood this one is taking the clock as, let us consider the clock is pi. Okay, now it is VDD and it is what? VSS. Now where should you have to take an output? Absolutely between PMOS and NMOS. This may be your output. Now based on this you can have 2 phases. First phase pre-charge phase, second phase, first phase pre-charge phase, second phase evaluation phase. Is it clear? We will talk about these two. Now let us assume that pi is equals to 0. What is happening if you observe that? If pi is 0, what is happening? You can clearly observe that when pi is equals to 0, this transistor will be turns off and this transistor will be turns on. Okay, even though these two transistors are turns on, is it clear? Because this transistor is in off condition, therefore you do not have any further path between output to ground. Is it clear? Then at the same time, then this transistor is turns on, therefore what is an output? If somebody asks you, absolutely logic 1 is an output. That means irrespective of the inputs you applied, what is an output you are having? Y is equals to 1 is an output you are having. Is it clear? That means it is not depending on the inputs. Even though inputs are not applied, it is moving to whom? 1. That is an important point you have to talk about. That's why it is known as what phase? Pre-charge phase. Is it okay? Now shall we see about the evaluation phase? If you talk about very clearly, let us consider now pi is equals to 1. If pi is equals to 1, this transistor will be turns off and this transistor will be turns on. Is it clear? Now we can't decide the output even though this transistor is turns on. Why? Because now we have to depend on whom? Inputs. Now if A, B is given, then you can decide the value of phi. Is it clear, all of you? That's why it is depending on the inputs. Now it is going to be referred as what? Evaluation phase. I hope that are you clear. Now you can cross check. If A is 0, B is 0, we know very well these two transistors won't be turns on. Is it clear? Now what is an output? 1 is an output. If A is 0, B is 1, that means this transistor won't be turns on, this transistor will be turns on. Okay, now there is no path here, therefore still the output is what? 1. Now if A is 1, B is 0, now you can consider here this is turns on, this will be in off position. Okay, now since pi is equals to 1 here, this will be in on position, therefore here also there is no path, therefore what is an output here? 1 is an output. Now at the last combination, A is 1, B is 1, you can observe that this transistor will be turned on, this transistor will be turned on because pi is equals to 1, this is always in on position. Now you are having a path from ground to, output to ground, therefore the output reaches to 0. Is it clear? That means even though pi is equals to 1, here it is depending on the inputs, therefore this is referred as which phase? Evaluation phase. Is it understood? In this manner you have to design any boolean function using dynamic Cmos. Is it clear? Now you can observe what is the advantage present in the dynamic Cmos, what is the drawback present in the dynamic Cmos. That is a crucial point you have to talk about here. Now you can observe, since clock is using here, first of all, okay, let us consider, first of all I will talk about the advantage. Now you can tell, since n plus 2 number of transistors are using, therefore less number of transistors. Okay, less number of transistors when compared to whom? Absolutely Cmos. Now will you please tell me how many number of transistors the Cmos required? 2 into n number of transistors. Let n is equals to 100. Now in dynamic Cmos, 100 plus 2, that means 102 transistors are required, whereas in Cmos 2 into 100, that means 200 number of transistors are required. Therefore dynamic Cmos is best when compared to Cmos. Now if you talk about drawback, okay, as one more advantage we can talk about. Okay, one more advantage we can talk about. What is the one more advantage? There is no static power dissipation. There is no static power dissipation. No static power dissipation. Is it clear? That is one more advantage you can talk about. This one very very important. Is it okay? Now you can talk about the drawback here. Drawbacks. Since clock is going to be used, okay, it is always continuously switching, therefore it occupies, okay, some high power. It consumes the power. Why? Because it is continuously switching. Is it clear? This is the first major drawback. And coming to the second major drawback here. Will you please guess what is the second major drawback present here? Anybody? Just observe and try to tell what is the major. Absolutely. You have to maintain synchronization. Because there is a clock. You have to talk about synchronous thing. And one more very very important thing is there. What is that important thing is nothing but cascade. There is a huge problem, that is a third problem, that is a cascade problem present in this structure. Why? Because you can observe very clearly you can observe. Let us consider, okay, you are having this structure. Let us understood. Okay, I am considering a 2 input NAND gate. Okay, once again let us consider this one. Okay, this is your pi, this is VSS, and this is VDD, and you can observe this one. For understanding purpose, I am shading this one, I am closing this one. You can observe this one, I am closing this transistor for your understanding purpose. Okay, let us carefully observe what I am doing here. Okay, now you can talk about. Let us consider this one is A, this one is B, and I have taken output here, and I am going to use one more dynamic CMOS here, same 2 input NAND gate I have considered here. Let us consider this is a master one. Let us consider pi, and this is A, and this is B, and there I have to consider output. This may be VDD and this may be VSS. Is it clear? Now here what is happening, you can observe very carefully what I am doing here. The output of this is I am connecting to the inputs. Is it clear? Okay, now you can observe very carefully. Let us consider if pi is equals to 0, we do not have any problem. If pi is equals to 0, we are directly here pre-charge phase, therefore the output is 1. Since the output is 1 here, is it clear? Are you clear? Since the output is 1 here, pi is equals to 0, you can observe that this won't be turns on, therefore there is no path present here, but there is a path here. There is no path here, but there is a path here. Y is also what? 1. Is it clear? Now you can observe very carefully the important point I am discussing now. When pi is equals to 1 here, okay, when pi is equals to 1, this transistor will be turns on. Okay, now since the output of this previously is what? 1 1. Is it clear? Therefore this transistor will turns on, this transistor will turns on, then the output goes to what? 0. I hope that are you clear. But actually what should be happen if pi is equals to 1? It should depends on this transistors, then it should produce an output, then this output should be cascaded to this, then it should depend on this. Is it clear, all of you? Then once again I'm telling that carefully observe what I am trying to tell here. When pi is equals to 1 here, this transistor will be turns on, this transistor will be turns off. Here also this will be turns off, this transistor will turns on. But previously what is an output producing this network? 1. Therefore this 1 is moving to A and B of the next stage. Then this transistor will be in on condition. Since this is in on condition, then you are having a path, it reaches to what? 0. I hope that are you clear, all of you. But actually what should be happen when pi is equals to 1, depending upon the inputs, the output should be produced, and this output should be forwarded to the next stage, then it should produce an output. Is it clear? Therefore, what is the major drawback present here? Cascade problem. Therefore, this type of thing is not this type of thing is not permitted in dynamic CMOS. That is a major drawback present in the dynamic CMOS along with the clock power and synchronization. Is it understood? To overcome this drawback, is it clear? We are having the next alternate gate circuit, that is a domino CMOS. Is it okay? We will see this in the next class. If you are having any doubt, you may ask. Thank you very much. Have a nice day. Okay, please comment.